Question 1, part C. We have to use Prim's algorithm to find another spanning tree for this network from question 1. In part B, we completed this matrix or table, and since part C is saying use Prim's algorithm, and it's not specifying whether I have to use Prim on the table or whether I use Prim on the original network, then I have a choice. I can either do it from the table method or just by looking at the network. In this video, I'm going to do it using the table. So let's make a start. Very first thing to do is to see whether we've been told where to start. We've been told to start at A. So in the table method, the first thing you would do is to completely delete the A row and then put a number 1 on the A column. Second thing to do is to now look down any numbered columns. Of course, to begin with, there's only one numbered column, and choose the smallest number. So my choices are 31 and 30. The smallest, obviously, 30. So this is the first edge that is part of our minimum spanning tree. So AC. Over the side here, I'm going to make a list of the edges as I add them to my tree. The question does say that we must clearly state the order in which we consider the vertices and the order in which we include the arcs. So the first arc is AC, and thinking ahead to part D, where we need to add up these lengths, I'm just going to put in brackets that AC is 30. So that was the first edge in our tree. Now that we've selected C and brought C into the tree, we now delete the C row and put a number on the C column. So C is going to have the number 2. And again, like I did before, look down all the numbered columns, not just the one I've recently numbered, but any column that has a number at the top. So here my choices are 31 or 22, 24, 29. Need to select the smallest of those, which is 22. So this represents the edge DC or CD. It doesn't matter whether you write DC or CD. So that length is 22. This brings the vertex D into our tree. So now I'm going to delete the D row and then number the D column. So the D column gets the number 3. We are deleting each row after we select a number from that row to avoid trying to reconnect D in the tree. And it's for that reason that in Prim's algorithm there is never any danger of having a cycle or circuit. We cross out a row when we've used it, so then we don't ever have a danger of including it again. Let's continue. We've now got 3 numbered columns. Need to look down all 3 of them and choose the smallest number that hasn't been crossed out. So my options are 31 from the 1 column, from the 2 column 24, 29, from the 3 column 24, 18 and 34. Out of all those numbers, 18 is the smallest, so this is the edge ED or DE, which has a length 18. Every time we select an edge in Prim's algorithm, it brings a new vertex into the tree. So we started from A, and then we brought C into the tree, and then we brought D into the tree. Now we're bringing E into the tree. So we delete the E row, so we don't try and connect to E again, because that would give us a cycle. So there's no danger of having a cycle because we've crossed out E. Likewise, we did with A and C and D. And E becomes the 4th to be numbered. I'm going to continue in the same manner as before, looking down all the numbered columns. The smallest number that hasn't been crossed out from all the numbered columns is the next one I will select. So my choices are 31 or 29 or 24 34, 26, 28. So 24 is the smallest of those numbers, and that's the edge BD. BD 24, and that brings B into the tree. So now B is part of the tree. Cross out B and number B. So 1, 2, 3, 4. B is numbered 5. Now looking down all 5 numbered columns now for the smallest number that hasn't been crossed out or already selected. Some choices are, well, there's nothing in the 1 column. There's 38 in the 5 column, and 29, 34, 28, 26. Smallest of those numbers, clearly 26. So G, E, 26, or EG, which is 26. I tend to write these edges in alphabetical order, so like AC rather than CA, and CD rather than DC, but it really doesn't matter whether you write alphabetical order or not. So EG 26, G is now part of the tree, so cross it out, and G will have number 6. So continuing looking down all the numbered columns, and the smallest number that hasn't been crossed out. So it's either 38 or 29, 34, 28, 21 or 33. Clearly it's 21, and that is edge F, G. Cross out F row, put a number, so that'll be number 7. And finally, there's only H left to bring into the tree. Looking down all the numbered columns, the smallest number that hasn't been crossed out is 33. And 33 is the edge HG or GH. And there we have the minimum spanning tree. And you need to remember to put an 8 on top of H and cross out the H row just to finish it off, because the examiner will be looking at the order of these numbers. If they're in that order, that shows the correct method. Plus, they're also going to be looking for the correct edges in the correct order and the correct circled numbers. But these numbers at the top is also part of looking for a correct method. So there we go. I've got full marks for part C. And while we're here, it's going to do part D. Part D asked us to find the length of our minimum spanning tree. And if we add up these numbers, we should get 174. There is a little check we can do in this question. So if you remember question 1 part A, we had to use Kruskal's algorithm also to find a minimum spanning tree. Now if you carry out Kruskal and Prim on the same network, then they might give you slightly different looking trees, but they will both be minimum trees, so they will both have the same total weight. So add up these numbers, and I got 174. Add up the same numbers from Kruskal's algorithm in part A. If I got 174 for part A as well, that will be a sign that, yes, we've done this correctly. So that's question 1 part C and D using Prim's algorithm on a table.